In this lesson, we'll define the inverse trigonometric functions for sine, cosine, and tangent. Let's start by looking at a graph of y equals sine of x. So that's this equation here in blue. And maybe I'll label a couple of points on it. Like, for example, in radians, over here at pi over 2, the graph takes on a value of 1. So you could say, well, if I take sine and I plug in pi over 2, I get 1. Or maybe we could also look at negative 3 pi over 2. If I put in this value, I get 1 as well. And then maybe one more value here. At negative pi over 2, sine takes on the value of negative 1. So here we just evaluated the sine function for 3 different angles. I could have picked any angles, but I just happened to choose these 3. The idea of an inverse function is one that reverses this process. So instead of going from the angle to a number, you want to go from a given number back to its corresponding angle. The notation that we use for this is arcsine. So this will be the notation for our function. And it's also abbreviated sine to the negative 1 power, which is read sine inverse. So if you see arcsine or sine inverse, this is the function that reverses this process over here. So it would take you from a value here back to an angle. So the question is, what is arcsine of 1? What does this thing equal? The way you'd figure it out is you'd look at your graph. So here's 1. And then you'd figure out an angle that corresponds to it. Oh, and here we go. The angle that it corresponds to would be pi over 2. So it seems like that might be the answer. But there's a problem. Sure, you get this point here, which refers to pi over 2, but you also get this point over here, which is negative 3 pi over 2. So, which is it? This should be a function, meaning if you put in one number, you should only get one number back. And here we have 2. In fact, this graph goes on forever in both directions. There are infinitely many angles for which arcsine of 1 corresponds to. So that's a problem. That means we can't truly define an inverse function on the entire domain of this equation. The trick is to restrict our attention to a few angles. So essentially, we're going to erase a portion of the graph that we don't want. So I'm going to highlight the portion of the graph that we're going to keep. We'll start here and go all the way to here. So the angles that we're going to use go from negative pi over 2 to pi over 2. When defining an inverse function for sine, you cannot use every single angle. But what you can do is go from here to here. You get every possible y value back that goes between negative 1 and positive 1, and you get no extra points. So going back to, what is arcsine of 1? The reason it's equal to pi over 2 is because that's the angle between negative pi over 2 and pi over 2 that corresponds to 1. And we've thrown away this value, so we're not using this portion of the graph as well. So this actually will define a function for us. So here, arcsine of 1, which is equal to sine inverse of 1 is pi over 2. By restricting the domain here, we've made sine a one-to-one function, and that means it does actually have an inverse. So now that we've defined what it means to be an inverse for sine, which here I'm calling arcsine, we can actually evaluate it for different numbers other than 1. So here I want to know, what is arcsine of 0, what is arcsine of a half, and what is arcsine of negative 1/2. Instead of referring to the actual graph of sine, I'm going to use the unit circle to help me answer these 3 questions. Now, for starters, when we're talking about arcsine, we're only talking about a few angles. Those are the angles that go from negative pi over 2 to pi over 2. I'm going to label those on the unit circle. So we're starting here, we're ending at pi over 2, and we're only taking the values that go between them. And we actually include the endpoints as well. So when we try to figure out answers for arcsine, we only want answers coming from this portion on the unit circle. All right, let's figure out what is arc sine of 0. So it's equal to some angle, which I'll call theta, but where is it? This is equivalent to asking, well, if I take sine of that angle, when do I get 0? An inverse function switches the inputs with the outputs. Okay, if you go over to the unit circle, sine is represented by the y value, and right here is where sine is equal to 0 because the y value is 0 here. So the real question is, well, what angle is this? In this case, this is an angle of 0 radians. So off to the side, I'll write, well, sine of 0 radians is equal to 0. And because of this, arc sine of 0 is equal to 0. So that would be the answer to this first part. So two important things. When I put this number into the sine function, it gives me 0 back. And furthermore, the angle is between negative pi over 2 and pi over 2. Let's try this for arc sine of a half. Okay, so for this one, again, the answer is going to be some angle, and that angle is between negative pi over 2 and pi over 2. This is equivalent to asking, well, sine of what angle is equal to a half? And knowing a few important angles that fall in the first quadrant are going to be very helpful here. So for example, I know that an angle of 30 degrees in sine gives me a value of 1/2 back. So let me draw that on here. So like this is a 30-degree angle, which is also pi over 6. And this is where sine is equal to a half. So this is knowledge that we have to bring in when trying to figure out, well, what is arc sine of a half? So at pi over 6, sine takes on the value of a half. Therefore, arc sine of a half would take me back to my answer of pi over 6. The important thing is that pi over 6 is an angle between negative pi over 2 and pi over 2. And so that's the answer for this next part. Okay, last one. What is arc sine of negative 1/2? What angle is this equal to? Again, we're asking the question, well, sine of what angle is equal to negative 1/2? And I think we can use the previous question here as a guide to get the answer for this one. I mean, the only difference is here the answer is positive and here the answer is negative. I know that sine of an angle in the fourth quadrant is going to be negative. In fact, if I went, instead of going up pi over 6, I rotated down here pi over 6. Like if I rotated down here, well, the y value at this angle, whatever it is, it's not going to be positive 1/2, but it will be negative 1/2. And what angle is it? Well, there are a lot of angles you could choose, but you want to make sure whatever the angle is, it is between negative pi over 2 and positive pi over 2. And I'm going to use negative pi over 6 to represent this angle. So that's the value that would go in here. And as a matter of fact, that is the value for arc sine of negative 1/2. Let's try a few more just using the other notation where we're using sine inverse instead of writing arc sine. Again, on the unit circle, I'm going to focus my attention to angles that go between negative pi over 2 and pi over 2. And we are including both of the endpoints. Okay, so to start with, sine inverse of negative 1. The answer is going to be some angle, and that angle falls between negative pi over 2 and pi over 2 inclusive. Well, this is the same thing as asking sine of what angle is equal to negative 1. Like this is the thing we're trying to figure out. On my unit circle, sine represents a y value, and this is where the y value is equal to negative 1. Well, that angle is exactly negative pi over 2. So sine of negative pi over 2 is equal to negative 1. That angle falls within this interval. Therefore, my answer up here is also negative pi over 2. All right, for the second question here, again, this should be some angle. Sine inverse of root 3 over 2. Okay, and this value that I'm seeing here, okay, this is coming from some very particular angle in the first quadrant. So I know that this is somehow going to refer to a 60-degree angle. So let me draw that in here. So here's approximately a 60-degree angle, and that is pi over 3, this angle here. And I know that sine of this angle is equal to root 3 over 2. That means the answer to this part is also pi over 3. For answering this question, I had to know some previous knowledge. I had to know that at a 60-degree angle, sine takes on the value of root 3 over 2. Pi over 3 falls within this interval, and so I'm done with that part. What about this one? Again, the answer is going to be some angle, which I'll call theta. Okay, it's negative root 2 over 2. That is immediately making me think, oh, okay, my answer is coming from down here in the fourth quadrant. The first thing I actually thought of when I looked at this is, well, sine of some angle is equal to root 2 over 2. Like, where is it positive? Now, I know that angle is a 45-degree angle here, which is pi over 4 radians. I know sine of pi over 4 is positive, root 2 over 2. But the only difference is I want my answer to be negative root 2 over 2. I know that means it's going to be, well, it was supposed to be a 45-degree angle down here. And that means I'm going negative pi over 4 instead of positive pi over 4. So here for this angle, sine of negative pi over 4 is equal to negative root 2 over 2. The reason that it becomes negative is sine's the y value. Up here it's positive root 2 over 2. And therefore down here the y value is going to be negative root 2 over 2. Our answer is going to be the corresponding angle, and that is going to be negative pi over 4. That is certainly an angle that falls between negative pi over 2 and positive pi over 2, and that's my answer. So we discussed the definition for the inverse of sine, which is arcsine, and one also exists for cosine, which we call arc cosine. So here I have my cosine curve going forever in both directions. So let me write that down. This is y is equal to cosine of x. And, just like last time, I was plugging some values in it, like if you look at cosine of pi, what is that equal to? Well, you find pi radians here, plug that into the function, and I get negative 1. And so that's the answer for cosine of pi. Over here, here's cosine of negative pi. It also takes on a value of negative 1. And so these values are coming from this cosine function. If you want to define arc cosine, we'll use this symbol, which you could also write as cosine inverse. And here I see there's a problem. The inverse function should reverse this process. So if you want to know, like, hey, what's arc cosine of negative 1, you should only get one answer back. So like you would locate, well, where's negative 1? It's here. Oh, well, maybe my answer is pi. But at the same time, you could say, oh, well, maybe the answer is negative pi. It can't be both. You can't have two solutions here. You should only have one. So just like with arc sine, what we're going to do is look at this cosine curve and just remove stuff that we don't need. Here's the way that is done. We start here at this point where it takes on a value of 1. We travel in the positive direction until we get to a value of negative 1, and then we stop. So this is our starting point. This is our ending point. So we're only using angles that go between 0 and pi. There are many ways that you can make the graph of cosine one-to-one by erasing portions of it. This is one way to do it. I mean, you could have gone from 0 to negative pi. I mean, that would work too. This is just the agreed upon standard way to do it, only using these angles here. And if you use this convention, now when you try to define arc cosine of negative 1, now there's no problem. You look at negative 1, you would not go over here because we're not using this part of the graph. Instead, you'd go here and you get your answer of pi. So let's try this in a few more examples. In example 3, we're going to evaluate these 3 inverse trig functions for these angles. And we just talked about this one in the previous slide, but I'm going to look at it again just by focusing on the unit circle. When we talk about the inverse of cosine, the angles that we are using go from 0 to pi. So it's different this time. It's definitely different than when working with arc sine. We need these angles. So from this perspective, if you want to figure out arc cosine of -1, the answer is going to be some angle. It's the angle that when you plug it into cosine, you get -1 back. There are a lot of angles that make this thing a true statement, but on the unit circle, if we go from 0 to pi, there's exactly 1. And that answer is here at an angle of pi. So cosine of pi is -1. Pi falls in the interval from 0 to pi. And so that's the answer. What about arc cosine of a half? Again, this is some angle. It's the angle that when you plug it into the cosine function, it gives you 1/2 back. And the half makes me think, okay, we're using some common angle from the first quadrant, either like a 30, 45, or 60-degree angle. And I just happen to remember that the angle is going to be a 60-degree angle. So let me draw that in here. That's going to be pi over 3. So we have to know ahead of time that cosine at this angle is equal to 1/2. And the last thing to ask is, well, is pi over 3 going to be my answer? Well, this part's satisfied, and also pi over 3 falls between 0 and pi. So it checks both of the boxes, and we have our answer, pi over 3. Perfect. But what about arc cosine of -1/2? What angle is that? Well, it's the angle that when you put it into the cosine function would give you -1/2 back. This is going to be a little trickier than last time. With sine, we just dropped down to the 4th quadrant and we had our answer. It was just the negative of the angle we started with. That's not going to work here. We're not allowed to go down into this 4th quadrant. In fact, we're going to have to go over into the 2nd quadrant. This is where cosine will take on a negative value because the x values, as cosine is defined, are negative. What angle is it? Well, the way I'm thinking about this is, I know I somehow have to refer back to the x value here. This was supposed to be 1/2. If this point gets moved over here, that's how I get my x value of -1/2. So I really need to know, well, what angle is this? This is an angle of 2 pi over 3. Because instead of going up pi over 3 here, we're going back pi over 3 here. This is 3 pi over 3. Back pi over 3 goes to 2 pi over 3. That was a little trickier this time. We couldn't just simply negate this angle. We had to find a corresponding angle here in the 2nd quadrant. Pi over 3 is the reference angle for 2 pi over 3, and 2 pi over 3 is going to be the answer. So what happened here is cosine of 2 pi over 3 does equal -1/2, and furthermore, that is an angle that falls within the interval from 0 to pi. So that's my answer this time. My answer is 2 pi over 3. In example 4, the same idea, I want to evaluate the following inverse trig functions. I'm just using the other notation of cosine inverse. I will also again mark on the unit circle the angles that we'll focus on, starting at 0 and going to pi. All right, let's look at this first one here. What is cosine inverse of -√3 over 2? Well, it's going to be some angle that falls within the 2nd quadrant because that is where cosine is negative. So cosine of whatever this angle is also going to be equal to -√3 over 2. I'm immediately thinking, well, do I know where cosine is equal to positive root 3 over 2? And I do. I know an angle where this happens. This angle is pi over 6, or that's 30 degrees. So, it's like roughly maybe something like this. Like maybe this is a 30-degree angle. So that's where cosine is equal to positive root 3 over 2. Now, that's not the answer to this question because, well, it's supposed to be negative. Okay, but I see what happens here. I want the angle that is going to be over here. So I need to figure out, well, what angle is this? What's this angle? If I were in the second quadrant, I know this is pi. That's also 6 pi over 6. If I go backwards pi over 6, this is an angle of 5 pi over 6. Cosine of this angle will give me the negative of what we had here. And therefore, since this angle falls within this interval, my answer is 5 pi over 6. What about cosine inverse of 4? I didn't mention this at first, but I added this, provided they exist. It turns out that this does not exist. So I'll put DNE for does not exist. Now, why is that the case? Cosine is defined by the x values that fall on this unit circle. And this is asking for the angle that gives you an x value of 4. Cosine can only take on values that go from positive 1 to negative 1. Cosine is never equal to 4. Like, I'll even draw it on here. If I extend this axis, here is 4. The circle never has an x value of 4. And because of this does not exist. So when you see cosine inverse, the only types of numbers that you can put in place of it are going to be between negative 1 and positive 1. And the same thing goes for sine inverse for that matter. So this doesn't exist because you can't put this number into this function. But what about this? Cosine inverse of root 2 over 2. What is this equal to? Okay, I think this is fine. Root 2 over 2 is about 0.7. It definitely falls within this interval. So the answer is going to be, well, it's the angle that when I plug it into cosine will give me positive root 2 over 2. I think we had something like this from last time. Okay, I know that this angle is going to be in the first quadrant. I know that is a 45-degree angle, or pi over 4. Cosine of pi over 4 takes on the value of positive root 2 over 2, and so that is my answer up here, pi over 4. And that's it for this problem. The inverse for tangent is defined in a similar way as our previous trig functions. So down here, I have the graph of y is equal to tangent of x, and it has a period of pi, and this thing is copied and pasted forever in both directions, so it goes on this direction forever and this direction forever. But just like with sine and cosine, this thing is definitely not a one-to-one function. So for example, what's tangent inverse of 1? Well, it equals an angle here, it equals an angle here, as well as here, and so on. The part of the graph that we will use for the inverse for tangent is this portion of the graph. This is everything from negative pi over 2 up to pi over 2. So it's a lot like sine, but the only difference is we cannot include either of these endpoints because tangent is not defined at those two places. So if we want to define the inverse for tangent, which is arctangent, our answers are only going to be from this interval, so nothing from here or there. So again, the symbols we will use is either arctangent or tangent inverse, and we're talking about the function that takes you from a value on this axis back to a given angle. Let's evaluate arctangent or tangent inverse for a few different values. I'll use the unit circle as a reference, and the angles that we are allowed to use fall between negative pi over 2 and pi over 2. So from here to here. The difference is between this and sine is that I don't actually ever want to get values back here and here. So let's figure out arctangent of negative 1. So I know the answer is going to be some angle that falls between negative pi over 2 and positive pi over 2. It is the angle that when you put it into tangent, it gives you negative 1 back. Now, I know tangent is positive in the first quadrant, so it must be an angle that falls down here. So really what I'm thinking is, do I know of an angle where tangent is equal to positive 1? Because if I know that, it'll be an angle in the first quadrant, I can then move it down into the fourth quadrant to get the correct answer. So I know an angle for which this is true. That angle is pi over 4, a 45-degree angle. This is where sine is equal to cosine, and since they're equal, the ratio tangent is equal to 1. That's not the answer to this problem. In fact, the angle I want to use is down here because this is where tangent is going to be equal to negative 1. This is negative pi over 4. That must mean since tangent of negative pi over 4 is equal to negative 1, and pi over 4, negative pi over 4, is between negative pi over 2 and positive pi over 2, that is the answer to this problem. Okay, what about arctangent of root 3 over 3? Some angle must be between negative pi over 2 and positive pi over 2. Because it's positive, I know it must be in the first quadrant. Okay, and here I have to use one of my familiar angles. It's either got to be a 30, 45, or 60-degree angle. I know it's not a 45-degree angle. In fact, it is a 30-degree angle, which is pi over 6. Tangent of pi over 6 is equal to root 3 over 3, and therefore arctangent of root 3 over 3 is equal to pi over 6. And that's the answer here. The last one, tangent equaling, or tangent inverse of root 3, what does that equal? Okay, well that must be the other angle that we did not use. So that is going to be this angle here, a 60-degree angle, which is pi over 3. Tangent of pi over 3 is equal to root 3. Pi over 3 falls between negative pi over 2 and positive pi over 2. Therefore, my answer here is pi over 3. So knowing sine, cosine, and tangent for these three angles is very important when trying to figure out the values for inverse trig functions.